Okay, so we're going to be having a look at stacks. And these are in our abstract data type structures. Abstract data types, for those of you, you did it in AS probably, but they are structures that we make inside of our code that behave in a certain way. That is not how they behave underneath. Therefore, the details of what is happening is abstracted from the person using it. Think of it similar to you turning on your television. When you turn on your television and you press the remote control button, you do not need to understand the underlying systems. To you, it appears that pressing the up button changes the channel. But actually, there's a whole lot of processing going on in between those points, circuitry and whatnot, and that's fine, but you don't need to know about it because of abstraction. And so stacks and queues and linked lists are basically data structures that are commonly used in programming, or abstract data structures that are commonly data types commonly used in programming. So here is my stack. I have an array, just the one, and I've got two columns, but the index is the index of the array, the number of the array, and then the data is what is actually in that position. Now, again, as with all of these things, the difficulty is there are multiple ways that these can be implemented. So we're going to just go with one way for now, but just be aware that in the exam, they might not give it to you in exactly the same way. So you got to be flexible and you got to be thinking about stuff, not just reproducing exactly what is given to you previously. So anyway, I'm going to have a variable, and that's going to represent the top of the stack. Okay, now the top of the stack is going to be set at the beginning to -1. And we'll see why in a second. And then I want to have a max stack. Okay, so I'm going to have max, and that's going to be the top. That's going to be the maximum number of elements, which is going to be the fifth one. That's the index of the highest element, not the number of elements. Okay, so a stack has two possible operations. Well, it has more potentially, but for us, we need to know push, which adds an item to the stack. So it's going to be push n for the number, or it's going to be pop, which is going to remove the item from the stack and probably return it or print it. So if I had something to push, let's say, that's going to be a letter instead. Okay, I'm going to push letter. So first thing I ask is the top less than the max? The answer is yes. So I add 1 to the top and then insert the data at that position. Okay, I'm going to add another letter, so I'm going to push B. Is top less than max? Yes, it is. So I'm going to add 1 to top, and I'm going to push B. And then again, push letter C. Is it less? Yep, add 1 and add. And then push D again, add 1 and add the data. And push E is is 3 less than 5? Yeah, so we're going to add 1 to top and add the data. And then here's the one we've got to be careful with, because this is where it can go wrong really easily. So push F. Now, is top less than 5 max? Yes, it is. So we're going to add F in position, sorry, should have updated top first, and then add in position 5. Now, what if I were to try and add EFG? I'm going to add G. I'm going to ask myself, is top less than the max? No, it is not. So I'm going to return an error. Now, what if I were to pop something? So pop just basically means remove. So all I'm going to do there is take the item at top. So I'm going to print or return F. And then I'm going to decrease the pointer by 1. Now notice we don't have to do anything with the data, we just move the pointer down, but effectively for us it means that that is now a free space. Yeah, even though it's still got the F in it, we don't care. I'm going to pop again, and so pop is going to take 4, output it in some way, and then change it down to 3. Now what if I were to call push on Z? Well, is the top less than the max? Yes. Add 1 to top, 4, and then put the letter in sorry, got to update that first, and then put the letter in that position. What did I say? Z. Okay, so that's the general basis of our stack. Okay, let's do it separately from the actual coding.